for section 6.1 in our book, starting a new chapter. In this particular section, the two things we're going to focus on is being able to find the arc length of part of a circle, and we're also going to deal with being able to find the area of a sector of a circle. Just part, like a slice of the pie is what we're talking about there. What's the area of that going to be? We're going to start out with arc length. When we talk about arc length, we're talking about the length of part of a circle. If you look at my example down here at the bottom, I got a circle, I got a central angle drawn in there. We just want to figure out, what's the length of what I got highlighted there in the red. Now, there's a formula that you'd use to do this. You just take whatever the radius of your circle is and multiply that by your central angle. Okay, so your arc length, we'll call it S, equals your radius times your central angle. And that central angle needs to be in radians, not in degrees. Okay, must be in radians. So make sure if you're given a problem and you got a degree measure, you got to convert it into radians. Okay, so we're going to do this example down here. The question says find the length of an arc of a circle with a radius of 10 meters that subtends a central angle of 30 degrees. Well, 30 degrees, first thing we got to do is change that to radians. If you remember your unit circle, 30 degrees is equal to pi over 6 radians. So that's what we're going to have to plug into our formula here. So the radius is given, it's 10. Okay, our central angle is pi over 6 radians. So let's plug that in. So the arc length, the length of this is going to be 10 times pi over 6, which is 10 pi over 6, which reduces to 5 pi over 3. And our units here are meters. Now, usually I just keep it with pi in the number. If you want to actually get a sense of what this is, I mean, you could do the approximation there of 3.14 for pi and multiply 5 times 3.14 divided by 3 to figure out what that is. But that's how we're going to leave our answer. It's an exact answer. If you do 3.14, then you're actually rounding it. You're not getting the exact answer. That's how you do a problem for arc length. Let me give you an example here to try on your own. I'll just give you, got a circle with a radius of 21 meters, and you got a central angle. Let's do a central angle of 15 degrees here. See if you can figure out what that is. As radians, plug it in. See what you can figure out there. So this is a good practice example for you. All right, I'm going to move on here. We're going to talk about area of a sector. Area of a sector, you can see in my diagram here, I want the area of what I have highlighted in the green. We're going to have a central angle, and I'm looking for the area now. How much is in here? It's like a slice of pizza or a slice of the pie. Again, we got a formula that we'll use for this. This is based off of the area of the entire circle and a ratio that you can use with the central angle. I'll just give it to you. If you have any questions on how to derive this formula, I can answer that tomorrow in class. But this is a formula that we're going to use. 1/2 times the radius squared times the central angle. And again, the central angle has to be in radians. So you might have to do some conversions when you're going through and doing a problem. Like down here, I got 60 degrees. I can't plug 60 degrees in there. I have to have it in radians. Okay, so in this problem, it said find the area of a sector with a central angle of 60 degrees. I forgot to put in the radius there. The radius of this circle is going to be 3 meters. So there's a central angle of 60 degrees, and the radius equals 3 meters. So let's find the area. I'm going to plug in what we know. So we got 1/2 times 3 squared. 60 degrees in the unit circle. If you remember the unit circle, 60 degrees is right about there. That's pi over 3 radians. Okay, times pi over 3. So here we got 9 over 2. Okay, when I get square, that's 9. It's over the 2 from the 1/2 and times pi over 3. That gives me 9 pi over 6, which reduces to 3 pi over 2 meters squared, square meters here, because we're dealing with area. So we got square meters. Again, if you want to figure out, a better number without having the pi in there, you can plug 3.14 in to get a better idea of exactly what that is and how much that is. I'd like to leave my answer with pi in it because that's the exact answer. Let me give you another one you can try. Um, try this one on your own. We'll give you a central angle here of 4 degrees and a radius of 45 meters. Okay, this is not on the unit circle. 40, well, it is on the unit circle, but it's not one that we've studied. There is a conversion. Remember that 2 pi equals 360 degrees. So see if you can use that to try and convert that into a radian measure. Okay, one last thing here. Trying to move along, get this done in under 10 minutes. Angular speed, linear speed, and the relationship between the two. When we're talking about angular speed, we're going to be talking about like revolutions per minute or revolutions per second. Okay, so like if I'm talking about angular speed, I might say something like the tire's spinning 125 revolutions per second. Okay, and you can convert that actually into an angle. Okay, because angular speed, what you're going to get, angular speed is going to be whatever your angle is divided by whatever your time is. So if you got 125 revolutions per second, okay, one revolution is 2 pi. So I can change this into radian measures by multiplying by 2 pi. So that gives me 250 pi. That would be my angle there. And the time here is given, it's over 1 second. So a lot of times when you're given angular speed, it's in revolutions per second. You're going to have to convert that into radians per second. So if I'm given this, then I got up here, I'll go ahead and write it down, 250 pi radians per 1 second. Okay, so a lot of times we'll have to convert that to deal with things. Linear speed is actually like a distance, like per second. Okay, it could be meters per second, it could be miles per hour. Let's do miles per hour. Okay, anything dealing with distance, like any of your distance units over time. Okay, and linear speed, you've seen this in physics class. Velocity equals your distance over your time. Okay, the relationship between the two, there's actually a formula that relates the two. Your velocity is going to equal your radius of whatever your revolution is if you're spinning something around, is going to be the radius times, we'll use W as your angular speed. Okay, I should write that up here. W is your angular speed. So this is something that we're going to talk about a little bit more in class. Actually, everything here we'll talk a little bit about more, but I wanted to introduce this to you here on this video. So, and we'll talk more about that tomorrow. So make sure you try the previous problems. Make sure you've tried the arc length stuff. Make sure you do this practice problem. Make sure you do the practice problem here with area of a sector. This is kind of a brief introduction into angular speed, linear speed, and the relationship between the two. We'll talk more about this in class tomorrow. That's all I got. Thanks.